Oops. Got to get back to the beginning. Okay, so today I am going to try to put two topics into one video, so bear with me a little bit here. But first we're going to learn to solve inequalities by adding or subtracting. And what you're going to see is that solving inequalities with addition and subtraction is pretty much like what we were doing before, where we had an equality, something like x plus 7 equals 10. So we still want to find all the values of x that satisfy the equation. There's not going to be one simple answer like we saw yesterday in the video. There's nothing to simplify, so I can go ahead and isolate the variable. Let me grab my pen here. And because I'm subtracting 7 from both sides, nothing's going to happen to that inequality. I've not changed anything about it. So I'm going to go ahead and subtract 7 from both sides of my equation. And I find that x is going to be greater than 3. And like I said, subtracting 7 from both sides preserves the inequality, so nothing has changed. I know that if I have a number greater than 3, it will satisfy this inequality. Okay, so the solution, this solution, x is greater than 3, is still an inequality. All right, and let's make sure that we know how to graph it as well. So I've got w minus 5 is less than negative 9. I'm going to do the very same thing on both sides, add our 5. And what I find is that w is less than negative 4. Well, less than negative 4, what is that going to look like? I've got a number line here. Less than negative 4 means I'm going to have, remember, the whole at negative 4, because it does not include negative 4. Sorry, really quickly picking that back up there. W was less than negative 4. I can't include the negative 4 because that's not included in my solution set, but any number that is less than negative 4. To be less than negative 4, remember, I'm going to go out this direction on my number line. All right, so let's go ahead and solve this inequality. I bet you can do this on your own. I will go ahead and solve this quickly for you. I'm going to add 0.1 to both sides, have done nothing to change the inequality. Oh, sorry, 3.5, sorry, is less than or equal to m. Okay, what I'm going to suggest is that you read this backwards. M is greater than or equal to 3.5. That'll just help you to be able to graph it, and we are going to do that. I've got my 0, 1, 2, 3, and 4. And I know that 3.5 is less than or equal to m, but m is greater than or equal to, so I'm going to have a closed-in hole. M is greater than or equal to. So let's quickly grab a different pen color, and probably not that good, but you can see that it is going off in this direction. Okay, here's a real-world application. A school bus can safely hold no more than 36 people. But after 6 stops, there are already 31 people on the bus. I need to write, solve, and graph an inequality to show how many more people can safely ride the bus. All right, so I am going to create a variable. I'm going to have P be the number of people who can get on the bus. So people who can get on the bus. Okay, I know that if the bus were empty, that my P, the number of people who get on the bus, would be less than or equal to 36. But I know that I already have 31 people on there. So I've got 31 people plus some number of people that can be on the bus has to be less than or equal to 36. Well, again, I can subtract 31 from both sides and not affect my inequality. I end up with P is less than or equal to 5. So I'm going to graph my inequality. Here I am at 0. Here I am at 5. I am going to do something a little bit different here, and that is, how many of you know of half of a person? I don't know any. So I'm going to tell you that I can have 5 people, 4 people, 3 people, 2 people, 1 person, or I can add 0 people to that bus. But notice I am not connecting those dots on my number line because I'm not aware of having 4.5 people. So if you can figure that out, you let me know. But otherwise, we're going to go ahead and just have circles filled in at the whole numbers. Okay. Oh, so that was my think about the reality of the situation. Sorry. Spoiled that for you. All right, Blake is saving money to buy a Blu-ray player that sells for at least $250. He has already saved $140. We need to write and solve an inequality to determine how much more money Blake has to save. So I'm going to make S the amount of money Blake still has to save. So amount still to save. So I know that I already have, I know that I'm going to have to save at least means it's got to be greater than or equal to $250. But I've got $140 already. So to that, I'm going to have to add some amount I still have to save. And that amount is going to be greater than or equal to $250. Well, I can go ahead and solve as I would any other equation. I end up with the amount left to save has to be greater than or equal to $110. And again, I could graph that. Okay, so here's what I'm going to do. I'm going to pause for a second and bring up my next slide. So what we're going to do here is go ahead and try to wrap up by doing multiplying and dividing already in this one lesson. We're still going to be doing one-step equations, but we're going to multiply and divide, which can get tricky. So first I want to get rid of that little negative sign. So before you write that down, don't add the negative sign. So we saw that addition and subtraction with inequalities still holds. Just like it did with equalities, right? So as long as I did the same thing to both sides of the equation, I was okay. But when we're doing multiplication and division, we're going to have some tricks that might get us. So because 5 is a positive number, we can solve this like we would any equality, and it's still going to hold as an inequality. So in fact, I can take my 5x and divide by 5 both sides, and I find that x is less than 4, and that will still be true. Okay? All right, so likewise, if I am going to multiply by a positive number, my inequality also will hold. So I'm going to go over here. I've got a 4 in my denominator. I can't have that. I'm going to have to multiply by both sides by 4. These sides cross off. So I've got y over here, and over here I've got 4 divided by 2, or 2. 2 is greater than or equal to y. Okay, so it's a positive number that I'm multiplying by, so this will not affect my inequality. Again, we're going to read this backwards. Y is less than or equal to 2. And let's look at another example. I've got 5 over 2x is greater than negative 5. So I do have a negative number over here, but my x, the coefficient on my x is not negative. So how am I going to solve this one? Well, I'm going to multiply both sides by 2 over 5, 2 over 5, and now this clears out and this becomes just 1x is greater than negative 10 over 5 or negative 2. Okay. All right, so no problem if we are multiplying and dividing by a positive number, but let's take a look at an interesting example. So I know that 2 is less than 4, but what happens if we multiply both sides by negative 2? So I'm allowed to do that. Remember, as long as I do the same thing on both sides of my equation or inequality, I should still be okay, right? So here I'm going to multiply by negative 2, multiply by negative 2, and what ends up happening? Negative 4 is less than negative 8. Does that make sense? No, think about your number line. Let me pull one up here. Negative 4, is that less than negative 8? No, negative 4 in fact is greater than negative 8. So here's what happens. My inequality no longer holds when I'm multiplying by that negative number. So this is going to alert us to the fact that if I multiply or divide by a negative number, my inequality is in fact going to flip, because negative 4, of course, is greater than negative 8. So what happens if I multiply by a negative number? I'm going to have to flip my inequality in order for that to continue to hold. So let's look at another example. So again, when we multiply or divide by a negative number, we need to reverse the inequality. So let's look at one. I'm going to here divide by negative 4. And to do that, I get my x, but I'm going to have to flip this so that x is greater than negative 3. Because like we just saw on the slide before, once I multiplied by that negative number, it actually made it the opposite situation. So we need to flip the inequality. Same thing happens when I am multiplying. Here I was dividing. When I'm multiplying, I'm going to multiply by 4. Does my inequality flip here? I end up with W and a negative 4 over here. So I do have a negative involved, but I was not multiplying by a negative number. I just had a solution that was a negative number. So my inequality is actually going to stay exactly the same. And remember, we're going to read that as W is less than or equal to negative 4. All right, so never one to leave you without a real world example. I've got Sajid, who received a $25 gift certificate. You're going to need to add that in there, to a movie rental website, and each movie costs him $4.50, including tax. So I want to know how many movies Sajid can rent and pay for with his gift certificate. So we're going to let V be our variable, and that's going to stand for the number of videos. So I know that each video is going to cost $4.50. And I cannot spend any more than $25. So I'm going to solve this, of course, by dividing both sides by $4.50. So, in fact, I'm going to find that V is less than or equal to, if I actually did that division, it's going to come out to 5.55. Again, like I said earlier in the video, how many opportunities do I have to get 0.55 videos? So how many can Sajid actually rent? Well, he can actually rent less than or equal to 5 videos. So if we were to graph that, again, we are going to graph that with solid points at each of the numbers on the number line rather than connecting it as a whole, because we're not going to have partial videos. All right, so that's it. There is a post-video quiz, and we will be doing some work on this tomorrow.